Hi, we are Team 1 from Group 505. This team is confirmed by Alan Antonio Castillo Jasso, me, Andrea Fernanda, Eduardo Azael, Adan Alberto, y Mikel Praticio, and we are going to present the Boyle's Law.
Hi, my name is Miko, and I will talk about Boyle's law statement. So first to know, Boyle's law states that at a fixed temperature, the volume of a gas is inversely proportional to the pressure exerted by the gas. This means that when the gas is pumped into an enclosed space, it will shrink to fit into that space, but the pressure that gas puts in the container will increase too. So then we have the mathematical expression for Boyle's law, that is P1 V1 equal to P2 V2, where P1 V1 is like the initial state and P2 V2 is like the final state. This implies that when the pressure on the gas is increased, the molecules are pushed closer together, reducing the volume. Decreasing the pressure allows the gas molecules to expand into larger volumes.
The constant value of Boyle's law are: P denotes the pressure of the gas, V denotes the volume of the gas, and K represents the temperature of the system and the amount of the gas. The value of K represents the product of ratio of pressure and volume for a fixed amount of gas at a constant temperature. It depends on the number of moles of the gas and the temperature.
In Boyle's law, pressure and volume use specific units. Pressure is usually measured in atmospheres and volume in liters. Temperature is measured in Kelvin, but in this law it is constant. For example, we can see values like 5 atmospheres and 8 liters. If the pressure changes to 20 atmospheres, the volume becomes 2 liters. These values show us how important it is to use the correct units. If the units are different, they must be converted to get accurate results.
Hi, my name is Adan Alberto Hernandez, and I'm going to present the problem 1 and 2. The problem 1 says a gas occupies 4 liters at a pressure of 2 atm. It is compressed until its volume becomes 2 liters. What is the new pressure? First of all, we need to have the data and know which data is missing. In this case, is the P2. And we need to use the formula that is P1 V1 equals P2 V2. In this case, we're going to clear the P2, and we are going to multiply P1 V1 and divide it by V2. And in this one is 2 times 4, that is 8 divided into 2, and gives us that the pressure is 4 atm. Well, the problem 2 is that a gas has 3 atm and 1.5 liters, and it decompressed into 1.5 atm. We need to know what is the new volume. Using the formula, we know that 3 times 1.5 is 4.5, and it is divided by 1.5. That gives us that the volume is 3 atm.
Finally, we have an example, that is our breathing. It's something that we daily do, and it's also a clear example of how this law can be represented in our daily lives. When we inhale, our lungs expand and the volume increases. This because they are filled with air. And the pressure decreases because the volume increases. And when we exhale, our lungs contract, and this decreases the volume and the pressure increases. And well, that's all for our presentation, and thanks for your attention.